Okay, I'm going to do 2 examples, and they're harder, but I'm going to use the same trick. And actually, we do this a lot in mathematics. You use sort of a trick to get around the hard examples. All right, and I'm still going to have to use some of the same rules I did before. All right, so the hard examples are if I've got an equation that has a couple of terms with fractional powers or a couple of terms with negative powers. All right, so the first example I'm going to look at is 3x to the 2/3 minus x to the 1/3 minus 2 equals 0. And I will check my answer graphically, and you can always find it graphically if you want to. I'm going to do it both by hand and graphical, because there's a trick we use. There's what's called the U substitution trick, which if you go into calculus, this is a trick, and there's actually U substitution rule, and so it kind of helps out in those cases. If you aren't going to go into calculus, though, again, solving it graphically would be perfectly fine. On the tests and the homeworks, again, you could solve it graphically. All right, but I am going to solve this using the U substitution. So what I can recognize here is this is both to the 1/3 root. This is 1/3 x to the 1/3. If I pull out the 2, it squares. And this is x to the 1/3 minus 2 equals 0, right? So I can split this fraction up into the 1/3 power and the second power. And I'm going to do that is because I'm going to replace x to the 1/3 with u. The fractional power is the one causing me the issues. And so I'm going to replace it. I'm going to do what's called a u substitution. I'm going to let u equal the expression x to the 1/3, and I'm going to substitute that out. And so when I do this substitution, I'm going to get 3 times u squared minus u minus 2 equals 0. And I put parentheses there, I don't really need them. Now it's a quadratic, and we know how to solve quadratics. All right, it's a quadratic. You can solve it however you want. It's already set equal to 0, so you can use the quadratic equation. You could use the any method that you have. Factoring is probably the best way, because that's what I'm going to get to, is I'm going to factor, because 3 is a prime and 2 is a prime, so they split up fairly nicely, so I'm going to do it by factoring, right? 3u and u will give me my u squared, and then I just have to figure out my negative. Well, if I do plus 2 minus 1, that'll give me a negative 3 and a positive 2, and it checks. Keeping this in mind, I'm going to have to come back to this. Alright, so 3u plus 2 will give me out a 0, and a u minus 1 will give me out a 0. And so I get u equals negative 2/3, and I get u equals positive 1. Now I've got to substitute back to get back to my original expression. And so now I'm going to replace my u's with my x raised to my 1/3 power. Alright, so now I've got these expressions I need to solve. I'm not done yet. Now I just have 2 of those simpler equations that we were solving in the previous examples. So if I x to the 1/3 equals negative 2/3, and I've got x to the 1/3 equals 1. And now I use the rules I did before. So this one I'm going to get rid of the 1/3 by cubing. And it's just a cube, so I don't do any type of plus or minus. And so that's just going to give me x raised to whatever, negative 2 cubed over 3 cubed. So 2 cubed is going to give me negative 8. 3 cubed is 27. And I don't believe that simplifies. And then over here, that should have been a cube, not a square. But it doesn't matter, because 1 cubed, 1 squared is still 1. And so there are my answers. And again, I should always check them. And I'm going to check them by checking them graphically. All right, so those are my answers. Negative 8 over 27, 1. And so I'm going to check it, and I'm going to do this by solving it graphically. Alright, so I'm going to start with my original equation, which was 3x to the 2/3 minus x to the 1/3. I keep wanting to do 2, 1/3. Minus 2 equals 0. And so I'm going to graph. So this is the plug into my graph. I'm going to go back to a standard window. Remember, I changed my windows in the previous. So 10 by 10 window, or you can hit zoom standard. Alright, 10 max, 10 min if you want to do it manually. Alright, so I'm going to graph that into my calculator, and I'm going to look at a standard window, and then I want to find the zeros, right? I have it set equal to 0, and so I'm going to find the zeros. And we've done this many times now in our previous examples. All right, so the graph of that, it's a weird V shape. And you'll notice that everything kind of happens near the origin. It crosses there and it crosses there. And so it comes down in this weird kind of V shape like this. All right, and I want to find the zeros. So remember how we find the zeros? Again, you go to that same place, you do second trace. But this time you're going to pick 2, which is the 0. And then it's going to ask you to go to the left of the 0, the right of the 0, and you do it for each one. And so there are 2 zeros you're going to find. All right, the first 0, if you find this one, you go to the left of it, make sure you go to the left of it and the right of it. So be careful, there's not a whole lot to the right of it. Don't want to go too far. Left of it to the right of it. So this is going to give me my decimal, and so that decimal comes out negative 2.963 if I round 2 decimal places. And that is the negative 8 over 27. If you take negative 8 divided by 27, this is the decimal it rounds to. All right, so that checks that. And then on the other side, if you do the same thing, second trace 0, so you find this, so you move your cursor over here, you do left of it, the right of it, and then you guess. And that does give you your 1, so it does check. All right, you could solve it graphically if you wanted to. All right, we got one more example that I'm going to do, which is again similar to this. We use the similar type of trick in the next example case, which is going to have negative exponents. But it's done very, very, very similar to this. Actually, I don't know if I have enough room, so I'm actually going to erase this so I have more room to work. All right, so the next example is going to be 8n to the negative 2. So I'm going to solve 8n to the negative 2 plus 14n to the negative 1 equals 15. So the first thing I'm going to do is I'm going to set it equal to 0. So I'm going to move the 15 over. 8n to the negative 2 plus 14n to the negative 1 minus 15. Right, if I move 15 to the other side, I subtract it. Then I'm going to do a very similar trick to what I did before. I can pull the 2 out here, just like I did before. N to the negative 1 raised to the second is the same thing. And I pulled the 2 out, so I was left with the negative inside. And the reason why is because I had n to the negative 1 over here, and I wanted those to be the same. Because I'm going to do a substitution again. I'm going to let u be n to the 1. That's my substitution. And so we get 8u squared plus 14u minus 15 equals 0. Now this one is a little harder to factor, right, but it does actually factor. You might want to use the quadratic equation or one of your other methods, but like I said, it does factor. If you use, actually, we'll use the quadratic equation in this case, since this one's a little tougher. All right, so the quadratic equation is the opposite of b plus or minus 4 plus or minus b squared minus 4ac all over 2a. And it works the same thing even if it's u's. All right, so negative 14 plus or minus the square root of 14 squared minus 4 times 8 times negative 15. All over 2 times 8. You do get 2 answers because there's the plus first, so do the plus and then the minus. And so you get, so when I do the plus version, actually I might simplify it before we go there. So negative 14 plus or minus over 16. So we get 14 squared minus 4 times 8 times negative 15. This is 676. Which is 26. All right. So u is negative 14 plus or minus 26 over 16. And so we do get 2 answers. All right. One of them simplifies to 4 over 3, and one of them simplifies to 2. Sorry. 4 over 3, 3 over 4. I wrote it backwards. 3 over 4, and the other one simplifies to 5 over 2. Let me double check that. This is the 0.75, which is 3/4 when I hit my fraction key, and that is 2.5 when I hit my fraction key. All right, so remember, I'm not done yet. Those aren't my answers. Remember what u originally was n to the negative first, and so remember, I've got to substitute back. N to the negative first equals 3/4. N to the negative first equals 5/2. So remember what n to the negative first really means. It really means 1 over n. And so it's asking you to find the reciprocal. If I want to solve this, this is actually that's what this is asking for. It's asking you to find the reciprocal of this. And so the reciprocal is 4/3. And the reciprocal of that is 2/5. And so that's the answer. So be careful. It's really easy to mess this up, because the answer is the reciprocal of the originals, right? Or not the originals, the u term. So the u term was 3/4. The answer is 4/3, because n to the negative 1 means I want the reciprocal, so I flip it. N to the negative 1 means I want the reciprocal, I flip it. So u of 2/5 is u of 5/2 is n to the 2/5. And those are your answers. Now I'm going to do the same thing. I'm going to check it graphically. So again, you have your graphing calculator. You could solve the whole thing graphically if you wanted to, but I'm going to check it. I'm going to graph it and show you solving it graphically. So remember, I'm going to graph my original. My original was, and so I've got to type them in as x values. So I'm going to change my n. Remember, it was n to the negative 2 plus 14 n to the negative 1 minus 15 equals 0. And so when you go to the calculator, you're going to plug those in as x's. And make sure you're careful. Put parentheses around your negatives. And you're going to find the zeros. All right, so make sure you're careful. When you type this into the calculator, make sure it's x to the negative 2 and x to the negative 1. Or if you wanted to rewrite that as 1 over x squared, that's fine too. All right, because this is the same as. So it's one of those rational equations that we solved in the last set. All right, so if we graph that, so I'm going to leave a standard window. I think a standard window should work just fine. So if we graph, so this is the function I'm graphing. All right, comes out. So crosses there, so it's coming up. Remember, it doesn't exist 0. Actually, just the same thing on the other side. Alright, so these are the values I want to find. Those are my zeros. So remember, you go to second, trace, you pick 2, which is your 0, and then it'll ask you left, right. And so you make sure you go to the left of it, the right of it, and then your guess. Alright, and so it will come out. This one comes out 1.333 repeating, which, not 1.33 repeating, that comes out 0.75. I did the wrong one when I typed in my fraction. That comes out 0.75, and this one comes out 0.4. So 0.4, which is 2/5, and 0.75, which is 3/4. Keep wanting to flip that. And so it does check. The answer is check. And like I said, if you are going on to calculus, knowing this U substitution trick can be quite helpful, because we do actually have a U substitution method, and it's just good. We do this a lot in mathematics. We kind of do use this trickery to get around the hard algebra. If you're not, or if again you're finding these sort of difficult to do by hand, you can always solve it graphically. All right, you could plug it into the calculator, graph it, and either find where they intersect like we did the previous case, or in this case set it equal to 0 and find the zeros, and that'll get you to the right answers. All right, so it's up to you how you want to do this. All right, but that finishes up chapter 4, so we're all done with chapter 4, and then we have chapter 5 as the next set of notes, so we'll stop there.